Hello, my name is LaWanda Hopefields, and I have the honor and the privilege of serving as the director for the Ronald E. McNair Post-Baccalaureate Achievement Program, also known as McNair Scholars. During this 2019-20 academic year, we are excited to celebrate our anniversary of 25 years on the Wichita State campus. Although during this year, we have encountered many challenges, as most of America has, we are so proud to still celebrate our students, and we have great appreciation for the faculty members who have stayed the course to bring this year's scholarly activities to a close. I would like to acknowledge my boss and mentor, Ms. Delta Q. Colvin, for her support during these most recent challenging times, but also for her confidence in me to lead this dynamic group of students. Miss Ashley Cervantes and Miss Nisha Green are the capable hands behind the scene, and a mere thank you is not enough for all that they do. They are the backbone of our program, and I am forever grateful. As we celebrate 25 years of academic excellence and 15 students who are completing their scholarly research, I also want to thank you as our supporters and as our listeners. Thank you for being there for the students and for the program as we celebrate 25 years of academic excellence. Enjoy these dynamic presentations.
Hello, my name is Stephon Edwards. I'm a McNair Scholar. I'm part of the Industrial Engineering Department here at Wichita State, and my study revolves around understanding people and technology, a theoretical analysis of time delay within NASA's autonomous mission operations. So during the evening of January 28, 1986, with thousands of people watching at home from the televisions, the Challenger rocket shuttle exploded seconds into flight, killing the inspiration to this research, Ronald McNair, and 6 other crew members on board. Nevertheless, the inherent engineering flaw that caused the Challenger incident was identified long before launch and caused major concerns, but was ultimately ignored by management as the launch was approved regardless. So with money and reputation in jeopardy, the management of both NASA and solid rocket booster manufacturer Morton Tokel were desperate to send a Challenger into space, willing to go ahead as planned despite the obvious risks. Since this infamous incident, several safety regulations and studies has been conducted to prevent the reoccurrence of such an incident. However, human error and actions caused from the disconnection between people and technology can never truly be abolished. Specifically, NASA currently operates with a communication delay present within their autonomous mission operations, affecting both the Mission Control Center on Earth and the operators within space. This communication delay could affect the communication between the Mission Control Center and the operators or the operators themselves during any specific mission. If this delay were to occur during a serious incident within space, it could result in the spreading of misinformation throughout all parties within NASA and could increase the possibilities of a catastrophic incident to occur. So through investigating the Challenger incident, NASA's current communication delay, and other such events, this study seeks to identify the hazards present to the relationship of people and technology. Ultimately, what repercussions could occur from technical or human error? So communication delay within NASA's autonomous mission operations is investigated through a secondary data analysis of previous publications within space operations involving the International Space Station, or the ISS, or the Deep Space Habitat Project, or the DSH. Additionally, various tasks and their correlation with communication delay will also be evaluated, including the following assessments. So first is human performance. NASA's crew members and various personnel's perception of communication delay will be evaluated. Based off the questionnaires measuring their rating of crew/team performance. Additionally, task criticality/level of emergency. The various tasks described within each space operation will be approximated using a measure within Lawrence's Palikot study describing the different levels of task novelty and task criticality, as shown within the table below. Finally, after the previous two assessments have been completed, the probability of human error within both space operations will be evaluated using two tables. First is a general maintenance human error table used by Joel M. Heitz and Rolf G. Cargini's case study within 2016, and a general probability table used by automation and technology company AB Controls. So for the results in the International Space Station, as discussed for human performance, as discussed within Lawrence's study in 2017, crew morale results found that crew morale was significantly lower under communication delay than under control, which was no communication delay, with stress and frustration being two of its most significant catalysts found. For task criticality / level of emergency, also within Lawrence's study, results found that the level of emergency had no significant correlation with communication delay under control or under communication delay. For human error probability, the probability of a simple maintenance error such as category G or H occurring within the International Space Station is estimated at 0.01. Additionally, the probability of the same scenario occurring due to high stress levels is estimated at 0.003. Therefore, based off the simple assumption that high stress is one of its direct consequences, communication delay could be responsible for adding 3 thousandths to the total probability that human error occurs within the International Space Station through stress alone. For human performance, results within the deep space habitat, for human performance, within Jeremy Frank's final presentation on autonomous mission operations within 2017, the results showed that there was no further interaction between communication delay and crew performance, but a significant interaction found between task configuration and communication delay. For task criticality / level of emergency, due to the novelty of the Deep Space Habitat project, the various task criticality or task novelty for each different assessment has yet to be determined. However, the project can be assumed to possess high novelty, which was previously found to have no significant correlation with communication delay within the International Space Station. For human error probability within the Deep Space Habitat project, the probability of incipient arithmetic errors, such as category E, occurring within the Deep Space Habitat project is estimated at 0.03. Additionally, the probability of the same scenario occurring due to high stress is estimated at 0.009. Therefore, based off the previous assumption that high stress is one of its direct consequences, communication delay could be responsible for adding nearly 1/100 to the total probability that human error occurs within the Deep Space Habitat project through stress alone. So as shown within the Challenger, NASA's current communication delay, and other such events, the possible repercussions from the disconnection between people and technology could be catastrophic. Specifically, communication delay has shown to have a prevalent effect on human performance and the probability of human error occurring within each designated task throughout both space operations. Nevertheless, this study utilizes a small subset of data under specific lab conditions, which is not 100% compatible to what would be found during operation. So in conclusion, the Challenger incident is one of the first noteworthy examples of unethical human error leading to a catastrophic incident to receive worldwide publications. Nevertheless, the events discussed within this research is only a simple reminder of how technical error could lead to an international incident due to the effects of human error. Through the pursuit of further human factors research within space exploration and other such specified fields such as medicine and manufacturing, financial or human loss can be further prevented within any future project or mission. These are my references. Any questions? Thank you. I believe that experimental data could produce different results because the data that was used within the previous publications utilized specific guidelines that are provided by NASA. For example, if an experiment was done within a college and had their own data found between any specific space operation, it could result in different data, which I had previously stated, which is why within the research I only utilize specific lab conditions, which if the results were used within just specifically from an actual prototype operation that NASA had done, it could result in different results. So it appears to not be statistically significant, but there are various catalysts that also add to this probability. This is just through stress alone. As the study showed, there are various things such as frustration or crew morale or other catalysts that could add to this probability very easily. Through stress alone, it's not that significant, but when added through all these catalysts and also the fact that the communication delay just simply makes it hard for operators to connect and talk with the Mission Control Center on Earth, it can very easily add up during a significant incident within space. Thank you for listening to my study on understanding people and technology, a theoretical analysis on communication delay within NASA's on-notice mission operations. I greatly appreciate this opportunity provided to me by the McNair Scholars Program. Thank you.